Today we are talking about multiplying fractions. First and foremost, I want to point out that when multiplying fractions, you do not need a common denominator, unlike when we are working with adding and subtracting fractions. So multiplying fractions is actually one of the simplest ways to work with fractions. All we are going to do is simply multiply across the numerators, so 1 times 1, and multiply across our denominators, 3 times 2. 1 times 1, of course, gives us 1, and 3 times 2 gives us 6. I cannot simplify this in any way, so this is my final answer, 1/6. Now, when it comes to multiplying fractions, we will sometimes have to simplify. So let's take an example, 3/4 times 8/3. Now, I want to point out that there are a couple of different places that we can simplify when we are dealing with fractions being multiplied. One is to simplify after we multiply across. So we have 3 times 8, which is 24, and I have 4 times 3, which is 12. 24 divided by 12, of course, gives us 2/1, which is just 2. But I can make my life a little easier if this works for you. And I can simplify before I actually do the multiplication. So I have 3 times 8 on top and 4 times 3 on the bottom. Now, I can simplify anything that is on opposite sides of that fraction bar. So if you notice, I have 2 3s here, one on top and one on the bottom. So those can cancel out to 1s, right? 3 divided by 3 gives me 1 in both spots. And then I have the 8 and the 4. 8 and 4 have a common factor of 4. Or even 2, so I divide by 4, I get 1, I divide by 4, I get 2, and that still gives me that final answer of 1 times 2 being 2, and 1 times 1 being 1, which simplifies to our answer of 2. One last example I want to point out is what happens when we have a whole number times a fraction. So let's say I have 1/9 being multiplied by 18. Now, I mentioned before that we multiply across our numerators and across our denominators, but this 18 here does not have a denominator written. What we have to do is we have to rewrite it with a denominator. Now, anything that is a whole number automatically has a denominator of 1. And I can say that's true because 18 divided by 1 gives me 18. So that is our way of rewriting this as a fraction, so that way I can multiply across my numerators and across my denominators. 18 times 1 is 18. 9 times 1 is 9. I can also simplify here and get 2/1. And 18 divided by 9 is, again, 2. And that is our final answer. What happens when we have mixed numbers? Well, let's say I have 1 and 1/2 times 3/4. First thing I have to do, anytime I'm dealing with multiplying fractions or dividing fractions, I need to make a mixed number into an improper fraction. It's crucial that we use improper fractions when multiplying or dividing with the fractions. So, 1 and 1/2, I'm going to use the C method personally, okay? Or I can use the get mad method, okay? Multiply, add, and then denominator. Basically divide, okay? 2 times 1 gives me 2, plus 1 gives me 3, divided by the original denominator of 2, 3/2. If I do this the other way, 3 divided by 2, 2 goes into 3 one whole time, that 1 whole, and I have 1 left out of the 2. Okay, so 3/2 is 1 and 1/2 in improper fraction form, and then I multiply by 3/4. Now, in this example, you'll notice that I have 2 3s, and a 2 and a 4. While the 3s and the 4 are common factors, they're not on opposite sides of the fraction bar, so I'm going to leave them as they are. I cannot simplify this because they're on the same side of that fraction bar. So for my final answer here, I have 3 times 3 is 9, and 2 times 4 is 8. Now I can leave this as an improper fraction of 9/8, or I can take 9/8 and say 8 goes into 9 one time, one whole time. And then I have 1 left over, right? 9 minus 8 is equal to 1 out of 8.